Hello everyone, I'm Max. Today I'm going to talk about the topic of reducing vessel noise increases foraging in endangered killer whales. Okay, then we started from what kinds of killer whale is mentioned in the topic. It is southern resident killer whale. I will call them SRKW or whales in the following slides. Southern resident killer whales are the smallest of three resident communities within North Pacific Ocean, and they are the only killer whale population listed under the Endangered Species Act. So this is why we have to do something to increase their survival rate. And their main food resources are salmon. We do our researches in Haro Strait and St. John Island. It is between Canada and the United States. And here is the critical habitat of SRKW. And this is, and then we talk about the three primary threats to the survival of southern resident killer whales, which are chemical pollution, prey limitations, and underwater noise. I think these threats are easily to be understood, so today we will focus on the underwater noise. A ship slowdown program takes place in 2018 in Haro Strait. Their aim is to reduce anthropogenic noise in Haro Strait. Anthropogenic means man-made. And each voluntary ship passed through Haro Strait must reduce their speed to 11 knots. As we know in the previous study, reducing 1 knot in speed can reduce 1 decibel in sound. And it works, they result in 2.5 decibel reduction. And reduced vessel speed will reduce noise amplitude, and it will minimize the damage in acoustic space used by whales. According to this function, it will make whales call each other more easily and track the prey more accurately, because they can hear the voice from themselves or their partner more clearly. In the study, we will focus on the accurate field light of whales and the vessels, and whales' behavioral data. Whales' behavioral data will be divided into 4 steps, which are foraging, traveling, socializing, and resting. Okay, then we talk about the purpose of this study. Our purpose of this study is to find out the likely effects of reduction in noise level from ships and boats on southern resident killer whales' foraging probability. And in our prediction, we think when the noise level is reduced, southern resident killer whales are more likely to surface and hunt their prey. We have 2 main methods. One is fine-scale field light, and the other one is scan sampling. Fine-scale field light is used to measure horizontal and vertical angles to whales and vessels. And this is the equipment look like. And the scan sampling is used to record whales' activity states and the distance between whales and vessels. And we will conduct it at a 5-minute interval. And when whales are within 10 body lengths of each other, we define them as a group. Our stations are located on the west side of St. John Island, and because Haro Strait is located on the west side of St. John Island, and our field light stations are located on the cliff of known height, this can make our figure out to accurate angle. According to the scan sample, we can get this figure. The x-axis is the location, and the y-axis is a number of observations. In this bar chart, you can see the significant different and it's lower. This is vessel presence and this is vessel's not presence time. And in this figure, we can figure out that pilot's vessel's appearance really disturb the whales. When we talk about our results, I want to talk about something you should know first. This is the vessel type we collect in our study, which are ship and boat. You can see, here's a picture, you can see ships are much more bigger than the boats. And for example, this is cargo ship, and this one is whale watching boat. In the study, the median distance between ship and whales was 7.5 kilometers, and the closest distance was 500 meters. And the maximum received noise level was 126 decibels. And in both, the median distance between boats and whales was 300 meters, and the closest distance was 5 meters. And the maximum received noise level was 143 decibels. Okay, in the left figure, we control our ship receive level at a percentile of median and 95th. And the x-axis was boats receive level, and the y-axis is probability of whales being in foraging or not foraging rate. I have drawn a line here to show that the same kind of red line and blue line, same kind, was complementary. So today we just focus on the red line. It means they're in foraging rate. And first, when we control our boat's receive level, there's a line here. You can see the more vessel noise we received, the less probability of whales being in foraging state. And when our boat's receive level increases, you can see a trend of decreasing in the whale's foraging rate. And in the right figure, it's the same concept. They just walk the boats and ship condition. From the previous page figures, we can conclude a final one without no ship condition. The x-axis is ship receive level, and the y-axis is probability will stop foraging. And in this figure, we can figure out that ship noises increases at the mean value of receive level from boats. Whales are more likely to stop foraging. Then we come back to our purpose and our expectation. We can check our study, our purpose of study, because we find out that reduction in noise level from ship and boats will increase southern resident killer whales foraging probability, and the result meets our expectation. In the last part of my presentation, I want to talk about something can be improved in the future study, same kind of study. One is to add some hydrophone in this study area. This can make our reports more accurately instead of we doing right now. We just find the raw data from the internet of the sound level. And the other one is to collect fine-scale data from the boat. Because no one has collected this kind of data before. And so this is make a study more difficult to recognize that boat is what kind of boat. So we just record it as a whale-watching boat. Thanks for listening.
So, except for the reducing vessel speed, and what can we do to reduce the received noise level by SRKW?
What can we? What the other method we can receive we can reduce the receive level from self-resident killer whales. Okay, we can do is to reroute our ship line or replace the noisiest ship in the fleet.
So there is a quite distance between the vessel noise and the detective measurement. So when the distance becomes longer, how did you know the vessel noise is a boat or a ship?
Okay, how do I know? Because the distance was long. So how do I know the vessel is boat or ship? And in this question, every observator has equipped a binocular, and they can check the size in the first time, and they will use AIS system, automatically identify system, to check the vessel's maritime mobile service identifier. It's kind of like the ID number to the boat.
Can you explain the 21 page again?
So we just control our ship noises at a median and 90 percentile. This is in our, we have collect a series of noise level, and we get this situation, and both x-axis is both receive level, and the y-axis is probability of being safe. And we just focus on the red line. Red line is their foraging rate. And you can see this is the decreasing rate, and when our boat's receive level increases. And this one is the thinner line is the most our ship receive level bigger. Yep. And you can see the foraging rate is lower. This one is here, 119.1 decibel. And this one is 102.8 decibel. Yeah.
Is there any noise affecting a whale except boat and ship?
Oh, is there any noise?
Backing.
Okay, backing the except for boat and ship. In this paper, they didn't do this kind of research. Yep. So I don't know. In that place.
You asked what is the question in your slide.
and it is page 21. What is the meaning of forage?
What is the meaning of foraging? This is foraging. Means they are eating.
All right.
I want to ask that your research is at a lake area between America and Canada, right? And is there any cargo ship? Yeah, thank you.
Oh yeah. Is there any cargo ship in the study area?
Lake area, yes.
I think they don't have the measure statistics. So I think there's not because it's a strait, and I would say the cargo ship as a sample is because it's quite easy to understand what is ship and boat's difference. Yes.
I want to know how do you count the number of the killer whales? You directly count it, or you use some facility?
How do we count the whales? Okay. In this one, we will use the fine scale field lights. We will find the whales in the study area, and we support with scan sampling. So we have scanned it and checked the number. Yeah.
I want to ask a question about you have a page that have two charts that is talking about the vessel present and non-present. Yes, and I want to know why the Lion King station has the more number of observations when the vessels present.
Okay. Why Lion King will have the more observation when the vessel presents? I have the same question in this paper, but it didn't talk about in the paper, and I think in the whole bar chart is a significant lower. Yeah.
So I think Max gave a very nice talk because I think you can follow his talk very well. That's the reason there were so many questions, and I think you have the same feeling that he talked at a proper speed, so you can follow him, and he explained some of the difficult terms, but I think you can explain more. I will tell you later. And his stage performance was also very nice. He had his body language. He was like standing here, letting you see his body and with some gestures. And then this graph, he had spent quite some effort. I think that's probably the most difficult graph in his presentation. And he really took time explaining this. But apparently it's not enough. So I'm not really clear what's really going on. So this can be improved. So and then and also you see that he added some icons so that you have the feeling that slides like this will give you a sense of style, because he used some icons, so it's a very easy way to improve the artwork of your presentation. All right, so let's talk about what can be improved. The first thing I would notice is definitely the unnecessary space here, there. So I was standing there, I really feel it's very small. So please, if you want to use icon, I was really thinking, what's that? I see it. It's yeah. So please, you don't need to have that much space. No. Of course, it's not Chinese paint, all right? You should take care of the people at the back. And then you have this SRKW, so you have to keep in mind that in a short talk like this, you should really minimize the use of abbreviation in general. I know you have only this SRKW, and I know you talked about this just 2 slides ago, but I already forgot. So what I will really do is, after introducing the slides, you can just say, below I will just call it killer whales. That's enough. Okay, and then stop using SRKW. I don't know what's that anymore. And then please explain, there's a slide where you talk about the behavior of the whales, right? And then what was really missing is you should put the keywords of the behavior. So you will answer Mandy's question, like what is foraging? You have to type the keywords here. And then another way to improve your slides, I saw you only do it here in few slides, is you can color your keywords. Because some like slides, this one or this one, you do that here. When you have more text, try to color your keywords. And of course, you should enlarge your text. It's in general too small. Enlarge your font. And then, when I was really listening to your talk, I like these 2 graphs. These are my questions. So the first thing is, how do you know, or how do you define received level? Is it received by the observer or received by the whales? That's something you need to explain, because the whales and the observer are at different places. So you need to first explain this. And second, how did the observer estimate the sound level? Because as you said at the end, they don't have a hydrophone. So how do they explain? You explain that a little bit in the Q&A session. And next time, please put it in your method section. So how do you estimate that? And you also need to define what's received level, all right? And the third is, well, this is really small. I couldn't read this label when I was standing there. So next time you can like add, like retype these labels yourself, make it bigger. Or you put just one graph. Because this graph is difficult enough, and you put 2 graphs, I was really overwhelmed. And these are really, really small. I couldn't read it at all. This. A better way to do this is just, maybe you just put the label or the legend next to the line. You know what I mean, right? You can check Fiona's presentation, that's what she did. And then the key point is now coming. You have to explain. The first thing is it based on observation or based on model? Which one? Tell us next time. I don't see any data points here. I assume this is based on model, all right? And then you, here you should tell us, this is not rate. This is probability. These are different concepts, right? Okay. And then another confusing thing is, I don't know the answer. Here we have many decibels, from 103 to 145, right? But here you have another value here. Why? No, you don't need to explain now. Explain next time. Understand, make it understandable to everyone. This was not well explained during your talk. So I just point out what was missing in your talk. All right? I hope this will help you to improve your presentation of this figure next time. But overall, it's a very nice talk. Let's thank Max.